Current flows in the coil on the right. By right-hand screw rule, it sets up a magnetic field towards the left. Based on Faraday's law, the increasing flux at the moment of switch closing induces an EMF in the coil on the left, causing a current to flow. By Lenz's law, the direction of the induced current will oppose the increase in flux it experiences. Note that oppose the increase in flux means that the current in the left coil will flow in the direction to resist or oppose the change in flux in the left coil. In other words, it is a kind of inertia in the left coil that resists or opposes changes in the flux through it. Therefore, the current flows from right to left through the resistor in the left coil. Note that the current in the left coil stops when the current in the right coil becomes steady. Current through the coil on the right increases. Therefore, the flux experienced by coil on the left increases. By Faraday's law, an induced EMF will be produced, causing a current to flow in the coil on the left to oppose the increase in flux linkage it is experiencing. By Lenz's law, the induced magnetic flux density will be in the opposite direction as the magnetic field set up by the coil on the right. Induced current will flow from right to left through the resistor R. Induced current stops when current in the right coil becomes steady. The coil on the left experiences a decreasing magnetic flux linkage. By Faraday's law, an induced EMF will be produced, causing an induced current to flow in the coil on the left to oppose the decrease in flux linkage it is experiencing. By Lenz's law, the induced magnetic flux density will be in the same direction as the magnetic field set up by the coil on the right. Induced current will flow from left to right through resistor R. The induced current stops when the circuit stops moving. The current in the right decreases to zero. The coil on the left experiences a decreasing magnetic flux linkage. Induced EMF will cause an induced current to flow in the coil on the left to oppose the decrease in flux linkage it is experiencing. The magnetic flux density will be in the same direction as the magnetic field set up by the coil on the right. Induced current will flow from left to right through resistor R. Induced current stops when current in the right coil becomes zero.